Assalamualaikum warahmatullahi wabarakatuh. Here I will present my final project. Let me introduce about myself. My name is Abid Zaidahul Barok from Program Study Design and Manufacture Engineering, NRP 0616040043. Title of my final project is Quality Control of Carbonated Glass Bottle Wall Thickness on Blue and Blue Process with Six Sigma Method. My supervisor is Mom Endang Puji Purwanti and Mom Widya Evelia Primaningtyas. My research background is the first demand customer of product is good quality. The machine Blue and Blue process can produce 211 bottles per minute. There are still bottle defect in inspection process. There is thinness of bottle wall, so make production is less efficient. My research purpose is knowing the cause of thinness carbonated glass bottle wall under standard and finding how to reduce of thinness carbonated glass bottle wall under standard. As for my research delineation, focus in machine Blue and Blue process in object carbonated glass bottle wall thickness, period March to June 2019. There are two input my research is primary data and secondary data. Primary data interview to supervisor quality control, manager and supervisor mall subdivision, and secondary data from reject data and metrology data. There are 5 steps. There is define, measure, analyze, improve, control. Define to make histogram and make SPOC diagram. Measure make to control chart and DPMO calculation. In analysis step is make a FTA, FMEA and calculation of RPN. Improve is action plan. And the last control analysis and interpretation. Blue and Blue process is glass bottle manufacturing process that use 2 steps of blowing. The first blowing to form a partition and the second blowing to form the bottle itself. About the types defect on bottle wall. The first ESSU inspect side wall stone upper. Defect because there are stone chips on the top wall of the bottle. ESSL inspect side wall stone lower. Defect because there are stone chip bottom wall of the bottle. EFBL inspect finish blister. Defect because there are bubble on the wall of the bottle. EPTB inspect panel thickness below. Defect because there are cysts on the wall. Thickness is below specification. This is a diagram of bottle wall thickness defect. ESSU 11%, EFBL 18%, ASSL 22%, where the higher percent is due EPTB defect, with a total 4,333 defect. So this is a focus of this research. This a defect diagram based on the shift, where the total percent per month is in March reached 21%, in April reached 22%, in May reached 24%, in June reached 29%. Morning shift always have a high percentage from March to June, so the defect EPTB March until June always has increased. SEPOC is a diagram that works to find out all of process that occur, starting from the procurement to material to customer. Start from supplier, input, process, output, and the last customer. This is an example from calculation in the first observation. Obtain value P 0.01153, calculation value of P bar 0.00948. First UCL calculation 0.01303. First LCL calculation 0.0597. So this do calculation until 30 observation. This is result of calculation from the first to 8 observation. This is result of calculation from the 9 to 16 observation. This is the result of calculation from the 70 to 24 observation. This is result of calculation from the 25 observation to 30. From the graph of proportion calculation result on the P chart control, there was a plot that went out of control by 10 observation. So it can be said that the EPTB defect has not been controlled statically. The next measure step are calculate value of DPMO to measure the capacity of the defect per million opportunity, and also to find out the level of sigma. Begin the finding the DPU value, then calculation of DPO value, so the DPM value is 2343. Then convert to DPMO to sigma value based on the Motorola concept. From DPMO value is 2343. Then convert to sigma table, obtain value 4.32 sigma. For 3 analysis diagram, from the defect in thickness of the bottle wall, defect glass bottle wall thickness caused by irregular mold blank temperature, unstable air pressure, change in blank mold design. Irregular mold blank temperature caused by the condition of blank mold is dirty, and blank mold has been replaced. The condition of blank mold is dirty caused by swap was done incorrectly. Unstable air pressure caused by change the air pressure setting, and change in pressure setting caused by the counter blow time is too fast and the final blow time is too fast. Change in blank mold design caused by blank situation there is damage, and caused by blank repair too often. This is FMEA table. We get an value severity occurrence detection from the questionnaire given to the expert judgment. There are 4 factors that exceed the RPN. 4 factors must be considered more. The first is blank mold has been replaced. The final brew time is too fast. The counter brew time is too fast. Blank repair too often. Improve step. This is a table of proposed corrective action as for some of the expected result from the cause of this failure. The first, no bottle of low temperature mold get into the leer. The second, bottle wall thickness, the result final blow evenly. Then the counter blow timing is still in the specified standard. Then there is no over repair mold to get into job change. And the last dirty mold issue is reduced. Control step. They resolve production of carbonated glass bottle wall for 7 days. Found defect 4,381 bottles of the total production of 2,187,360 bottles. The percentage of defect product is 0.20% of total production. DPMO value is 501. They convert to sigma table, so that a score of 4.79 sigma is obtained. The previous score is 4.32 sigma. On the analysis and discussion on the calculation of sigma value, there was an increase of 0.47 sigma from a value 4.32 sigma to value 4.79 sigma. With that said, the higher the sigma value achieved, the less potential for error in production. from the sigma value is mean that the potential for error in production decrease, so the number of defects due to thinness of the bottle wall to be a little. First conclusion about factor causing defect. The first, blank mold has been replaced. The final blow time is 2 hours. The counter blow time is 2 hours. Swap was done incorrectly. Second conclusion about effort in reducing. Manually reject bottle that come out of mold that have just been replaced, which has the higher RPN value from the other factor. Check the panel periodically during the job change process to check the final blow timing and counter blow timing to comply with specific standard. Check mold lifetime and number of repair before job change so that no over repair mold used for production. Swap the dirty and dry mold and check regularly so the temperature of the blank mold is stable. This is about documentation. The first, production with blue and blue process. The second, the process of checking the setting panel, and then the picture about taking the temperature of production result, and the last, the production after printing and enter the inspection stage. Thank you very much.